Bismillahirrahmanirrahim. Sallallahu alaihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alaihi wasallam. Ameen. Alhamdulillah rabbil alamin. Speak well or don't speak. This is the advice for everyone, including me. Circular measure, lecture 1. Circular measure. Some important points regarding this chapter. The calculator must be in radian mode. Observe the given diagram carefully. Understand the concept of the radius of the circle. This distance is also radius, because when you will work in sector, you will find this type of distance. So this OB is also radius. Radius is center to circumference distance. The distance from arc to center is known as the radius. The chord and the perpendicular from the center to the chord. Now you have done this in O-level mathematics. The perpendicular from center to chord always bisect the chord and makes 90 degree with the chord. So this property is very important, and this length OA is the radius. Tangent perpendicular to radius. You have done this property as well. Tangent is always perpendicular with radius. I'm repeating this point. Calculator must be in radian mode. Formula. And for this sector, O, A, B, the arc length formula is S is equal to R theta. If you need arc length of this sector, then use this formula. S is equal to R theta. And if you need the area of this sector, then you should use either this formula, half R square theta, or half RS. So it depends on the given situation, what kind of information is given. If theta is given, then use this formula. If arc length is given, then use this formula. Well, area of side angle side triangle. This triangle is side angle side because two known sides and their common angle are given. So to find the area of side angle side triangle, we use this formula, half AB sine C. And according to this triangle, this formula will become half R square sine theta. Right angle triangle is very important, and for right angle triangle, if you have hypotenuse, this is the hypotenuse and this theta. If these two things are given, then you can easily work for opposite. It will be R sine theta and adjacent will be R cos theta. Make sure you write these two directly in order to save time. But do these two things when hypotenuse and theta both are given. This will make your calculation very fast and will save your time. Cosine rule. Now we use this rule for two types of triangles: side angle side triangle and side 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 triangle. Normally in circular measure we find side angle side triangle. So this is the side angle side triangle because there are two known sides and their common angles. So in order to get this length, we can use cosine rule. So according to cosine rule, we can write this as AB square is 15 square plus 15 square minus 2 of the formula 15 times 15 and cos pi by 3. Alternate method. This method is very important if you want to save your time, and if you want to avoid the use of cosine rule, you should use this alternate method. In this method, we drop a perpendicular from O to length side AB. Since this triangle is isosceles, therefore this perpendicular will bisect the length AB, and then we can suppose this length and this point, you can suppose this point as M, and this length AM can be supposed as x. So you need to work for AM. Get AM and then multiply AM by 2 to get AB. So first get AM. So for AM, since AM is the opposite and we have hypotenuse, so we should use sine pi by 6. So this is the value of AM. So when we will multiply this with 2, you'll get AB, which is 15. This is the easiest method than the cosine method. Sine rule. You have done sine rule in O levels. We use sine rule when a pair is given. Pair means a side and its opposite angle. If both are known, then this thing is known as the pair. So when a pair is given, then always use sine rule. In this triangle, if you need the length, if you need this angle theta, then you should use sine rule. So sine theta over 20 and sine pi by 3 over 15. And you know how to simplify this. Tangents from P, you all know, you have done this in O levels, that tangents from external point to the circumference of a circle are always equal. So this AP, you can say AP is equal to PB, or you can say PA is equal to PB. So when these two tangents are equal, then you know this is 90 degree and this is right radius. So these two triangles are congruent. Congruent means every corresponding thing of both the triangles are equal. So if this angle is pi by 6, then this will be pi by 6. And if this is pi by 3, then this will be pi by 3. And you know, if you add these two, you'll get 2 pi by 3. And if you will add these two angles, you will get pi by 3. And if you will add both, then you will get pi. So the sum of these two angles will always be pi. This is very important. So if we have this angle 2 pi by 3, we can easily get this angle, or vice versa. And with the help of this 2 pi by 3, we can easily get this angle. This is 4 pi by 3, because the total angle of a circle is always 2 pi. Of any circle is always 2 pi. Well, this is semicircle, and you have done this property in O levels, that angle subtended by diameter to the circumference is always 90. So this angle is 90 degree, and since these two are radius, this one is also radius, so this triangle is isosceles and this triangle is also isosceles. Since this angle is theta, therefore this angle will be pi minus theta. We already have done these formulas for any sector. You can use S is equal to R theta for the arc length, and for area you can either use this formula or this formula. It will depend on the given situation. Well, if you need area of this shaded region, then you need to just write larger area minus smaller area. Area of sector minus area of triangle will give you area of shaded region. And in perimeter, make sure you understand the concept of perimeter. Perimeter of shaded region is the sum of the boundaries of the shaded region. Now this region is occupied by two boundaries, this and this. So if you will add these two, you will easily get the perimeter. AB plus arc length will give you perimeter of this shaded area. Well, this is right angle, so I already have told you, you can directly write the length of opposite and the length of adjacent, since hypotenuse is given and this angle is theta. When hypotenuse is given and theta is given, then you can easily write the length of adjacent and opposite. Well, for area of shaded region, and this is very important, this OB is also radius, because the radius is the distance from center to the arc. So you can easily get this length, CB. CB will be OB minus R cos theta. So area will be sector minus triangle, and perimeter will be this length plus this length plus this length. Well, you have done this thing as well in O level, angle relationship between cone and sector. So when you will, whenever you unroll a cone or any cone, you will get a sector. So the transformation is here. The slant height converts into radius, whereas the circumference of the base of the cone converts into arc length. So you just need to remember these two things. Circumference converts into arc length like this, and slant height converts into radius. Make sure you write small r here and capital R here, so that these two r will not be mixed. Convergence from degrees to radians. Well, these are some important conversions. 180 degree is equivalent to pi radian, 90 is pi by 2, 60 is pi by 3, 45 pi by 4, 30 pi by 6, 362 pi, and 273 pi by 2. You must know these things, and this will help you in the calculation, during the calculations. Convergence. So the best method for the conversion is ratio method. If you want to convert 135 degrees into radian, you just need to use cross multiplication. Just use ratio method. 180 is pi, so 135 will be x. Just do cross multiplication and you will easily get the answer. 180 pi x 135, do cross multiplication and you will get 3 pi by 4. And the second method is this box method. If you need your answer in radians, then you just need to multiply your requirement with pi by 180. Let's suppose if 135 is given, you just need to multiply 135 by pi by 180. I mean, you just need to remember this thing, that when you need answer in radians, keep pi in numerator. When you need your answer in degrees, keep 180 in numerator. What if you want to convert 3 pi by 2 into degrees? You just need to multiply 3 pi by 2 with 180 upon pi. So if you need your answer in degrees, keep 180 in numerator. If you need your answer in radians, keep pi in numerator. Complementary angle relations. You need to remember these three important relations. These are very helpful during the calculations. Sine pi by 2 minus theta will become cos theta. Cos pi by 2 minus theta will become sine theta, and tan pi by 2 minus theta will become 1 upon tan theta. Make sure you handle this angle carefully. What if we had x here, and you should write x here. Commonly used Pythagoras triplets. These are some commonly used Pythagoras triplets. These triplets will make your calculation very simple and fast. If 3 and 5 are known, then the remaining one will be 4. If 6 and 8 are given, then the remaining one will be 10. 5, 12, the remaining one will be 13. 24, 25, the remaining one will be 7. I mean, these triplets will make the calculation very fast. Well, this is all. We have done the explanation of circular measure. I will discuss the solution of some important questions of circular measure in my next lecture, inshallah. And this is the advice for everyone, including me. Think before you speak. Allah Hafiz.